In addition to what we covered beforehand about adding and subtracting moments of inertia, there's also a theorem called the parallel axis theorem, which allows us to calculate moments of inertia of an object given that we know the moment of inertia about the center of mass. So given the moment of inertia for an object with an axis of rotation through the center of mass, denoted I sub cm, the moment of inertia about the axis displaced from the center of mass, distance d, remaining parallel to the original axis is moment of inertia equal to the moment of inertia at the center of mass plus the mass of the object times the d squared, which is the distance of displacement from the center of mass. So let's see this in action. Let's consider the following. We have a rod of uniform mass density rotating about its center of mass, shown here by the dotted line, and of length L. And we can find the tabulated value as the moment of inertia about the center of mass for a rod of uniform density is equal to 1/12 mass times the length squared. Now, what I want to find is the moment of inertia about an axis through the end. And so I want to displace it by the amount shown here in red, L over 2. So I is equal to ICM plus question. What is it equal to? What is my displacement? What is D in the quantity up here, D squared? Well, that's going to be equal to 1/12 ml squared plus the quantity over here on the last term on the right hand side, m times L over 2 squared. And that's going to be equal to 1/12 ml squared plus 1/4 ml squared. Well, 1/12 plus 1/4 is what? That's equal to 1/3 ml squared. All I did was take the original center of mass, add to it the mass times the amount I displaced the axis, and I come out with my 1/3 ml squared. What is the tabulated value? Well, guess what? It is 1/3 ml squared. So the parallel axis theorem gave me the right value. So if you don't know the moment of inertia about an arbitrary axis, but you do know it about the center of mass, you can calculate the moment of inertia about an arbitrary axis. End of module.